Good morning and welcome to the STS-70 post-flight press conference. We have with us this morning Shuttle Program Director Brewster Shaw and our Entry and Landing Flight Director Rich Jackson. We'll hear comments from each and then take questions. Brewster?
Okay, thanks, Jeff. STS-70 got off to a good start back on the 13th, as you recall, with a very good launch, and we were fortunate to have weather that cooperated with us. Also, you probably remember that that was the first flight of a Block 1 engine upgrade, and the data that we've gotten back so far on that engine indicates that it performed as expected very well. And also, as you probably know, the TDRS satellite that we carried to orbit is on station and being checked out, and everything looks very good with it. The rest of the flight went extremely well. The orbiter performed very well. We had very few in-flight anomalies on this mission, and we accomplished all of the objectives. Rich and his team had a good deorbit plan going into yesterday morning, and they executed it properly, and that resulted in a safe and successful landing this morning at Kennedy. And the crew is back in the crew quarters, and everybody feels really good. So I don't know how things could have gone much better.
Rich?
Okay. As obviously we waved off yesterday due to the weather conditions we had at Kennedy, this morning we came back in. We were shooting for the first opportunity on KSC 141. When we rolled around to deorbit time, the conditions were observed go, forecast go, but considering the circumstances we've had to deal with at Kennedy Space Center for the last couple of days, knowing that the forecast held through the second opportunity, we elected to go ahead and remain on orbit and shoot for the second opportunity to ensure the conditions would meet our criteria for landing. And as it worked out, it went just as expected. SMG folks, our weather support Steve Sokol, was right on the money in terms of outlining the forecast for both the first and second revs. He was right on in terms of the forecast, and the conditions were great. It was a picture-perfect day to land at Kennedy, and we accomplished that at about 8:02 Eastern, and Tom flew the orbiter to, I mean, just a picture-perfect landing. Couldn't have asked for anything better. The vehicle did handle or perform extremely well, and that's kudos to the Kennedy processing folks. They did an awesome job in preparing the vehicle. As Brewster mentioned, the in-flight anomalies were extremely low. All of those were minor, and we had nothing to work around in preparation for deorbit and landing. I guess the only other thing to mention is what did complete the first flight with us being in the new Consolidated Control Center, and that facility performed flawlessly. We're really excited about it. Look forward to proceeding with the next several flights in that facility and proceeding to march on over for ascent entry support in there in the very near future. With that, that's all the comments I have.
Okay, we'll proceed directly to the Kennedy Space Center and take questions there. Please give us your name and affiliation before stating your question. Go ahead, KSC.
This is Marcia Dunn of the Associated Press for Mr. Shaw. I'm wondering if you could discuss the STS-71 booster anomaly, and given the problems with booster seals over the course of the program, why did you launch Discovery before having a chance to thoroughly evaluate the Atlantis SRBs?
Let's see, STS-71. On the disassembly of the RSRMs for STS-71, as you know, the field joints are disassembled at the Cape, and the inspection of those field joints during disassembly revealed no abnormalities. Then the hardware is shipped back to Utah, where it goes through the rest of its processing to make it ready for another flight, the hardware that's reused. At Utah, at the Thiokol facility, the nozzles are disassembled, and as you're probably aware, the nozzles are made up of several segments which are mated together, and they comprise several joints in the nozzle assembly. In the number 3 joint on both the left and right-hand nozzles out of the 71 motors, we had experienced gas paths through the RTV backfill that is put into the joint between the sections of phenolics after the joint is bolted together. The left and right-hand 71 nozzles comprise the 12th and 13th experience of gas paths through the RTV backfill that we've experienced on the RSRM motor program to date. And on the 71 left side, we observed that the gas path went through the RTV to the primary O-ring, as we have seen previously. We had some soot, which is combustion product, near the O-ring, and we had a potential indication of some heat effect on the primary O-ring at the location of the gas path. On the right-hand side, we had a gas path that allowed the hot gas to reach the O-ring. We saw no indication of any heat effect on the O-ring on that side. So the difference with respect to the 71 motors and our previous experience is that although we have seen gas paths many times, as I mentioned, and we have seen soot at the far end of the gas path, and we have seen heat effects on the phenolic insulation at the location of the gas path, this is the first time that we have seen any indication of heat effect on the primary O-ring itself. So that is the difference, and that step is a small step in our experience base, the fact that there was an indication that we had some heat effect on the primary as opposed to just heat effect on the phenolics at that location. So that's the difference between 71 and the previous motors that we have flown. Then you asked, why did we not examine those motors before we flew 70, I believe. We don't have a requirement to completely disassemble all of the solid rocket motors and look at every aspect of the solid rocket motors before we fly a next flight. We try to get as much of that done as possible with the time that we have available, but we don't have a documented requirement to complete that work before we fly again. And our history and experience with these RSRMs to date has been very good, and throughout the course of the RSRM program so far, that's given us confidence that we do not have to take the time necessary to totally inspect the motors, all aspects of the motors each time. And this indication that we have seen on the 71 left-hand motor, so far in our look at that abnormality, so far we have not seen something that would indicate that we would have to change our policy in that regard.
And a follow-up question, what does this mean for STS-69? Might it be delayed, and what about following missions?
Well, I don't really think that we're going to have to delay 69. We have a team in place of engineers from the Marshall Space Flight Center, and they're working with a team of the Thiokol engineers to examine this abnormality and determine what the potential causes of it are. If the abnormality is of enough concern that we need to take some action to preclude it happening again, and what that might be should it become necessary. Those teams are relatively early in their work in evaluating this, so we don't have a final answer yet, but the information that I've been provided with so far tends to indicate that this is not a serious enough occurrence that we would have to delay a subsequent flight. We're also have shipped the STS-70 motors, at least the nozzles, back to Utah. They're en route now, and we'll be looking at those this week. And that'll be another data point in our experience base with those motors, and so we'll see what that looks like. But currently, I've not seen anything yet that indicates that we're going to have to stand down or delay STS-69.
Phil, John Earth News, Rich. Can you talk a little bit about the weather decision today for the landing? How marginal was Edwards? I understand the weather was starting to get bad over there. Was there any consideration to staying up an additional day if the weather wasn't good over here? And just how much of a judgment call was it to make the decision to come ahead and come to the Cape for this pass?
Two things. One, as just a review of our flight rules for this, when we're down to our 2 extension days, one of which is a weather extension day and one which is a systems day, we basically look at both the primary and the secondary landing sites to ensure that the weather is predicted to improve at the primary landing site while maintaining good weather at the secondary landing site. And the forecast yesterday showed that Kennedy would improve somewhat and that Edwards was forecast to be go. We came in this morning, the forecast for Edwards was still go. The winds had picked up a little bit more than what we had predicted, but they were within limits, and this vehicle was unique in the fact that the mass moment of the vehicle would have had us landing on the lake bed as our primary landing runway. And that basically gave us all the options of the runways out at Edwards, so the wind was essentially of no consequence at Edwards. In terms of the forecast and the conditions at Kennedy, and what we had to work with as we came up close to the first opportunity and then the second opportunity. As you're aware of, yesterday the conditions were fairly bad at Kennedy. We had very, very low clouds and restrictions to visibility in the order of 2 to 3 miles, well below the minimum criteria for a shuttle landing. We, to be honest, when I came in this morning, I didn't hold out a lot of hope, but Kennedy turned around really nicely. We came in, like I mentioned earlier, our SMG forecaster, Steve Sokol, yesterday before we left console, had commented that he was under the inclination that the first opportunity might be our best and did not want to pass up either of the two. We came in this morning, or actually last night, and started watching the conditions, and what we had to deal with the previous 24 hours just did not develop. It remained clear and no restriction to visibility at the Cape right up to essentially sunrise. When we got around to the first opportunity, the forecast had been amended just prior to the deorbit burn to give us go obs and go forecast. And based on the conditions that we had to deal with yesterday, based on the fact that the forecast was holding for both the first and second opportunity, I elected to hold off for the first opportunity and wait until we did get through sunrise, and the go decision for the second rev was well after the minimum temperature for that morning, so we could see exactly what was going to occur in terms of fog and restrictions to visibility. Basically, between talking with the SMG folks and the flight control team, we decided that would be a prudent thing to do based on the previous 3 or 4 days at the Cape. And again, the forecast was go for both opportunities, and that seemed like the prudent thing to do. As I'm sure everyone's aware of, fog is something that can develop fairly quickly, and just elected to take the conservative action in that case. I do have to commend our SMG folks, though. They were right on the money. In terms of when we rolled around to the first landing opportunity, it was just as predicted. There was essentially no cloud deck and no restriction to visibility, and that held through for the second opportunity. So they did an extremely good job, and I think it was just, we had the luxury of being able to take a more conservative approach, and that seemed the prudent thing to do.
Rich, let me follow up on that. The general attitude I've seen, especially towards launches, but also towards landings here, is that once you got a good opportunity, you go for it, because everything can always change afterwards. I haven't seen any delays to launches in order to improve payload performance or vehicle performance or anything like that. It seems like you took a little bit of a risk that you gave up a good opportunity for a better one. Can you address that?
Well, I think there's 2 things. One, with the launch, when we're dealing with weather, for launch, abort type landing, that's your very extremely low probability type event. When we're dealing with landing, we're going to be very confident of the conditions we're flying into before we commit to a guaranteed event. Secondly, the conditions we were fighting today, the forecast was go for both opportunities, and the period of concern resided right around sunrise. and waiting for the second opportunity got us through that period of concern and basically allowed us to look and see exactly what the worst case conditions were going to be before we committed to deorbit. And since we had that luxury, that was the prudent thing to do.
This is Jim Banky of Florida Today. Booster questions more for Brewster. First of all, between now and the next launch, when do you want to have this issue put to bed and resolved? Is it an L-2 kind of thing, or do you expect it sooner?
No, I expect us to be to wrap it up prior to the L-2. We're going to work it hard the next week and see where it goes. The Dr. Blair team from Marshall is very actively pursuing that right now with Thiokol engineers, and I expect that we'll have resolution prior to L-2.
And as technical problems go in characterizing this problem versus any others, how serious is it? I mean, you start using words like O-rings and gas pass, and everyone starts thinking a Challenger. How does this compare, relate, and how big of a deal is it?
Well, I don't know how to compare it. If you're referring to Challenger, I don't know how to compare it to Challenger. We're not talking about the same joint. This is an indication in a nozzle joint, and they're a little bit different animal than field joints. We treat every unusual occurrence, abnormality, unexpected event with the solid motors as very serious. And everything that happens to us relative to that hardware, we look at very closely to make sure that we understand the phenomena that's occurring, we understand the causes, we understand the limiting conditions, and we understand the potentials of what could happen. And I think that's the appropriate approach to take with those motors. As you know, once you light them off, they burn until all the propellant is gone, and you don't have very much control relative to that. So we look at everything with respect to those motors very seriously, and we convince ourselves that we understand what's going on and that it's safe to continue operating that hardware before we do so, when we see something that's abnormal.
Todd Halverson of Florida Today for Brewster. Published reports indicate that you might be considering grounding the fleet over this booster problem. Is that a possibility?
Well, anything's possible. As I said earlier, I have not seen data yet that would lead me to believe that that is going to be a required course of action. But anything is possible. We need to understand what happened. This is a small step outside our database. We have to make sure that we appreciate the potentials there and that we understand the limits of this phenomenon.
And just a couple of quick follows. Am I correct in assuming that these hot gas paths neither got past the primary nor the secondary O-rings?
That's absolutely correct.
And I'm wondering whether you've been able to do any analysis whatsoever of the nozzle joints on 70, or if that's something that you haven't been able to do yet because they're en route to Utah.
That's right. They are en route, as I said, and so we haven't had an opportunity to examine them. When they get to Utah, they'll be examined this coming week.
Okay, and just one other. The fact that you found this problem after the STS-70 launched, does that raise any concerns about the 6-day turnaround between missions and whether that might be a prudent course in the future?
I don't think it's going to turn out that way. Of course, anything is possible with respect to this hardware. If we did, for example, find that we had a serious problem on the 71 hardware and we hadn't looked at it prior to committing the next hardware to usage, and it could be something that might affect multiple sets of hardware, then we might be disappointed that we took that course of action. In this particular case, I don't think it's going to turn out to be that way, but as I say, we don't have very much data yet. We just have the observation. We're trying to run some offline tests and do some analysis to understand it, and I really don't have enough information yet to make a determination.
This is Sue Butler. In retrospect, was the 71 crew ever in danger? And when exactly during the 2-minute, 4-second flight or so did the O-ring problem occur? And was it just singeing, suiting the O-ring, or was there actual holes in it? And if so, can you give us some dimensions?
Let's see, one at a time here. The STS-71 crew, it turns out, was in no more danger than any other crew, the 70 or any of the previous ones. In other words, this phenomenon on the left-hand motor did not place them in any greater danger. We can't tell what time in the motor burn yet that the gas path occurred. It's a natural phenomenon based upon the way the RTV backfill process is done, that it's possible as the phenolics erode during the course of the burning of the motors that you would uncover or open up a gas path if the RTV, the shape of the RTV in the joint is such that it is not as deep at one location as at another. If the phenolics erode down to that level, then you can open up a gas path. And that would tend to happen later in the burn of the motors, but as I said, in this particular case, we don't have enough data yet to determine when that happened. And the effect on the O-ring itself, no, there was no hole in the O-ring. The O-ring sealed as it was designed to do. No gas got past the O-ring. The description of the heat effect on the O-ring is like shiny spots on the O-ring where the hot gas impinged on the O-ring. The blowhole in the RTV tends to focus the hot gas as it comes through and pressurizes the small volume between the RTV and the primary O-ring. And as that gas is focused, it tends to put more heat in a localized area on the O-ring, and that's what can cause those indications.
Glenn Swanson with Countdown Magazine. Because this is the last flight of Discovery before going to Palmdale, would it have been at all cost effective to intentionally land at Edwards instead of here at KSC?
No, actually it would have meant 2 ferry flights instead of 1. The facility at Palmdale that we use for OMDPs currently is not outfitted to be able to handle an orbiter that has propellants, hypergolics, some of the other fluids on board. So we have to deservice the vehicle, and in fact we take off the OMS pods and the forward RCS and replace them with just molded shapes for the ferry flight out. We can't take those systems into the facility at Palmdale, so we have to deservice the vehicle at Kennedy.
Colonel Shaw, this is Dick Giuliano from AP Radio. And given that you say this is the first time you've seen this heat effect on the primary O-ring post-Challenger, and given that the Rogers Commission was especially critical of NASA for continuing to fly when you knew you had a problem, what is it about this nozzle joint gas path or blow-by that gives you the confidence to say it's not serious enough to delay subsequent flights?
Well, the nozzle joint, as I mentioned earlier, is a different animal than the field joint. The nozzle joint is essentially a static joint, and that means that when the motor's pressurized, the joint doesn't tend to open up as it does in the previous design of the field joints. So the O-ring is not required to track any opening motion. It's pretty much static. And so the design and the condition that the joint experiences is different than the field joint was on the previous design of the SRM. And the fact that you pressurize an O-ring with the hot gas, the motor combustion products, is not something that you should not expect. And indeed, that's why the O-ring is there, is to be pressurized by the hot gas and to hold that gas in the form of a seal. The RTV backfill is applied as a thermal barrier to protect the O-ring, and in most cases it does. But the way that that is put in place, as I mentioned, does set up the potential for a gas path and the pressurization of the O-ring. But that's what the O-ring is designed to deal with. And so it performed, in this case, it performed exactly as it was designed to perform. The O-ring served as a seal and kept the hot gas where it was supposed to be.
As a follow-up, Colonel, you point out correctly that we're talking about two different joints, Challenger and this one. However, wasn't it nozzle joint leaks that predated the Challenger accident that particularly caught the engineer's attention? 61C, the flight before Challenger, had a serious leak in the nozzle joint. Are you saying that you are satisfied with the design? It's not a design problem.
I don't believe we have a design problem. I don't think we're going to have to change the design. We might decide that we want to change the process of applying the RTV backfill some. I don't know if we're going to decide that or not. We're going to have to wait and see what the offline testing shows us and decide whether we can do something to improve that situation. But as I said, the joint performed as it was designed to perform.
Todd Halverson of Florida Today for Brewster with a couple. Can you tell us what the failure scenario would be for a total burn through of that nozzle?
All of the joints in RSRM that contain the hot gas are considered to be CRIT 1 joints.
What would be the effect in flight of a complete blow-by through that nozzle?
Well, you'd have to assume that if you violated the integrity of the joint, you would have hot gas flow. And we know that sustained hot gas flow can erode the phenolics and erode the metal. So you would, if that were to happen, you would open up a hole in the nozzle itself, and it's very difficult to predict what that would result in. But we consider it to be a criticality 1 situation.
Okay, and how many IFAs did you end up with on this particular mission, STS-70?
I don't think I know exactly the number, but it was very few.
Yeah. I think the last count I had yesterday, I believe it was just about 8, and the thing that needs to be stressed when we say 8 IFAs in terms of dealing with the orbiter hardware itself, a lot of that is involved with things like cameras, our carry-on equipment, if you will. So the orbiter overall was very, very clean, and all of those were very minor.
Okay, and it seems to me that there's been quite a downward trend in the number of IFAs you guys have been experiencing on flights over the past several years. What does that say about the ability of the orbiter, which a lot of people think are old 1970s space jalopies, to perform?
I think there's two things that go into there. One is that it's basically the low in-flight anomaly rate is due to two things. One is a tribute to the processing team, that we process and test the hardware and ensure it's ready to go fly. Secondly, due to the fact that we have some history on this vehicle, when we first started flying it and the in-flight anomaly rate was a little higher, we learned from the failures that we have on orbit. And we come back, the engineering support goes through, basically takes each of the hardware components apart, determines what the cause was, and if appropriate, identifies a redesign and folds that back into the fleet. I think both of those aspects are what's contributed to the extremely low in-flight anomaly rate that we're picking up now.
Bruce, this is Sue Butler again. You mentioned that the nozzle joint is a different animal altogether, which brings up the question, and I do not know if it is directly related to the O-rings, but on at least 2 occasions, and possibly more, you had the carbon phenolic fail in the nozzle throat. At least I think it was the nozzle throat, and you came once within 4 seconds of a complete burn through. Are you examining these nozzles for that too? And what is the status of that? Could cause a burn through as well as an O-ring. So what is the status of the nozzle carbon?
The answer is yes. We do examine them extensively after every flight and look for all of those types of indications. We haven't had any problem with the phenolics in the nozzles for a long time. In fact, I believe since a return to flight, we haven't had any significant problems with the phenolics. What you're remembering was quite early in the SRM program.
Okay, and I believe that was the final question at KSC. A couple of quick announcements. I believe today at 1 p.m. Eastern Time, we're anticipating a press conference at the Kennedy News facility with the STS-70 crew. I'd encourage you to stay in touch with the Kennedy News Center for any updates to that. We anticipate the STS-70 crew returning to Ellington Field here in Houston at 5:30 p.m. local time, and I would encourage those of you who are interested to stay in touch with the JSC Newsroom recordings for any further updates to that. Thank you very much.